Hi everyone, this is N.YASWANTH. Today I am going to explain about my project Home Automation using IoT. My team member is N.LOKESH and the contents of our project is Abstract, Introduction, Features, Requirement, IoT, Embedded System, Arduino IDE, PiximLab, Blink IoT app, Design Component, Application, Conclusion, Output and the project demonstration. The main abstract of this project to develop a home automation system using an Arduino IDE using PiximLab and Blink IoT app. As technology is advancing, so houses are also getting smarter. In order to achieve this, PiximLab is interfaced to Arduino IDE with the using of a serial port emulator, which is nothing but a null emulator. A Blink IoT application on the cell phone sends on or off commands to the where loads are connected. By touching the specified location on the Blink IoT, the load can be turned on or off remotely through this technology. Introduction to this project, the home automation refers to the automatic and electronic control of household features, activity and appliances. In simple terms, it means you can easily control the utilities and features of your home via the internet to make life more convenient and secure, and even spend less on household bills. Read on to find answers to some of the most common questions about home automation technology and get a few ideas for home automation solutions to incorporate in your home. Home automation is a network of hardware communication and electronic interfaces that work to integrate everyday devices with one another via the internet. Each device has sensors and is connected through a Wi-Fi, so you can manage them from your smartphone or tablet whether you are at home or miles away. The features: remote access. We all know that being able to control devices remotely means that things link unlocking the door for a planned site without having to leave a key under the mat. And the comfort. When you are all comfort in bed but realize you have left the bathroom light on. With smart light bulbs, you can turn them off from the comfort of your bed without having to leave those lights bulbs. You can turn them off from the comfort of your bed without having to leave those high thread count sheets. And the energy efficiency. How many times have you left the heat on blast while you have out of the house for 8 hours? With home automation, you can set the things link thermostats on schedules to make sure you are not wasting energy. A study found that Nest thermostats in particular can save about 12% on heating and cooling cost. IoT. IoT is the Internet of Things, describes physical objects or groups of such objects with sensors, processing ability, software and other technologies that connect and exchange data with other devices and systems over the internet or other communication networks. Internet of Things has been considered a misnomer because devices do not need to connect to the public internet. They only need to be connected to a network and be a individual addressable. The field has evolved due to convergence of multiple technologies including computing, commodity sensors, increasingly powerful embedded systems and machine learning. Traditional fields of embedded systems, wireless sensor networks, control systems, automation independently and collectively enable the Internet of Things. The requirements of our project is main the knowledge about embedded C and C++ programming and LED, temperature system, LDR sensor, serial tank or serial communication, Ethernet shield, Blink IoT app. Comes to the embedded systems. Embedded system, a combination of hardware and software which is intended to do a specific task, can be called as embedded system. An embedded system is a combination of computer hardware and software designed for a specific function. Embedded system may also function within a large systems. Comes to the C. C is a structure-oriented programming language. In this, it is a programming language which has been used for a game programming, software engineering, data structures, operating and applications, etc. In this C, many of the programming language has its own data types. Like like that only C also have its own data types, which are mentioned here. Uh, Comes to the character. This is one type of data type in C programming. It size is 8 bits and occupies 1 byte. Its ranges from -128 to 127. Unsigned characters. Unsigned characters are always a positive, which is ranges from 0 to 255. Int, we know integers are 1, 2, 3 or 0 and so on. Negative value also consider. Its size is 16 bits, which means 2 bytes. It ranges from -2 power 15 to 2 power 15 minus 1 and so on. These are listed here, some data types. And comes to the project applications and requirements. First, the Arduino IDE is main required for the project. The Arduino integrated development environment or Arduino software contains a text editor for writing a code, a message area, a test console, a toolbar with the buttons for common functions and a series of menus. It connects to the Arduino hardware to upload programs and communicate with them. This is the interface of Arduino IDE. Here, this is a toolbar which we can choose for a file, edit, sketch, tools and help, and this is quick action buttons. This is for verify and this is for compile and this is for upload. Here open file tab, which we use to open a different files, and code editor. In this code editor we have two sections. One is a void setup and a void loop. In this void setup we can run the code at only one time, and the void loop, the main code here is run repeatedly as like a loop. And here it is a status bar and console window, which the program is compiled successfully or not. Here we can see the errors of the program and board inform. Next comes to the PixSim Lab. PixSim Lab is a real-time emulator of development boards with integrated MP Lab or AVR GDB debugger. PixSim Lab supports some microcontrollers from PixSim and some from UCSim. PixSim Lab have integration with MP Lab Arduino IDE for programming the board controllers. As the support of PixSim Lab is to emulate real hardware, it does not have any source coding editing support. For code editing and debugging, the same tools used for a real-time board should be used with PixSim Lab, such as MP Lab X or Arduino IDE. Comes to the Blink IoT app. Blink was designed for the Internet of Things. It can control hardware remotely. It can display sensor data. It can store data, visualize it, and do many cool things. By using this app only, we can control the all IoT devices through our mobiles. Come to our project. In this home automation project, we use Arduino IDE PixSim Lab simulator and a Blink Android application. This home automation project contains measurement of a temperature, indication of a water level, and control garden lice. First, we want to write a Arduino IDE code to the Arduino IDE board. After writing the code, we will dump that code to the Arduino board. But here we are doing the software project by using IDE and PixSim Lab. Instead of physical Arduino board, we can implement the program in the Arduino board and execute in the PixSim Lab. PixSim Lab is a real-time emulator of a development boards with integrated MP Lab. Already we discussed that. First, we have started with Arduino IDE to implement the code of various sensors. We have various code which we require in this project. After implementation of the project, we need a software, so we need run code and get output of the code. So using PixSim Lab, we get the output, and we use serial port simulator which connects Arduino IDE and PixSim Lab. This is the sample representation of our project by using a Blink app through our mobile and a Pixim lab. From the Arduino IDE, we can upload the program to the Pixim lab and execute in the Pixim lab. Next, design components. Design components, it is a ETHW5500, which means a Ethernet. It is used to connect devices in a network and is still a popular form of network connection. Next comes to the temperature system. It is a temperature system which is used to uh, measure the temperature of a system, and it has both cooler and heaters. And light dependent resistor, which means LDR. It is used to control LED lights. And design components, next come to the LCD HD44780. It is used to display the values and it supports to the I2C module. Next, serial remote tank. It is used to see the how much in-valve flow and out-valve flow of the water in a tank. After execution of our program in Pixim lab, we can see the water level in the tank using this serial remote tank. And next come to this is the overall output of our project. The main advantages of our project is managing all of your home devices from one place only. Remote control of home functions, maximizing home security, save effect on time, increasing energy efficiency. The applications of our project is through this home automation project, we increase or decrease the room temperature according to user comfort. With the help of Android application, when water tanks fully filled, it notify user. By using LDR sensor in this project, we can control our garden lights. Conclusion. Using Blink IoT application and Pixim Lab simulator, simulated home automation where LED, temperature system, serial tank resembles light, heater, cooler and water tank in real time. CLCD acts like a dashboard for displaying the events, gas, widths to display the temperature and volume of the water. Main purpose of home automation is to provide easy lifestyle via control different home appliances with the help of Android application which is easily available in smartphone. With this, we save electricity, time and money. Next, the demo of our project will be explained by my teammate N.LOKESH.
Hello everyone, this is Lokesh. I am here to show and explain about the demo of the project and home automation using Blink IoT application. For this, we are using Pixim Lab. First, we need to go to the tool and open the serial remote tank. We need to go to tools and we need to open serial remote tank. We need to select the serial port and we need to select a null emulator setup. Here we have the virtual pair and select any two pairs. Here I am selecting two pairs of COM6 and COM7. COM6 is connected to the Pixim Lab and which is virtual connection, and COM7 is connected to serial remote. We can see it in Pixim Lab. COM7, we can see the control out of the water flow, inflow of the volume increasing. Now here we need to switch on the garden light using LDR sensor. The sunlight is decreased. The switch of the LDR sensor. Now by raising the switch, we can see the light is blinking. It means the light is glowing. While decreasing, it is going less. You can observe on the picture that it is glowing when the switch is at high position, and it is going low when we decrease it. You can observe on this Pixim lab board. Now we can increase and we can decrease the light. We can see that the light is glowing and the light is going to off. We can see it in a blinking option also. Move to the move on to the temperature of the system. For that I need to display my screen. This is my mobile screen. Now I am opening Blink IoT app in my mobile. I designed as two tabs here. The first tab related to the temperature system and this second tab related to the water system. Coming to the first tab, I need to switch on the cooler by clicking on the cooler. Clicking on, we can see in the Pixim board the fan is running and temperature will be shown in the display. Now we turn off. If we turn off, the fan will stop rotating and we can see the temperature. Again, if we turn on, the fan is rotating and temperature is increasing. If we turn off, it comes to normal state by taking some time. Now, if we go to now again if we turn on the cooler, it will rotate, fan will rotate and the temperature will be decreasing. Now coming to tab 2, here if we here we take this, in this we will fill the water and we will release the water. Now if we turn on the valve, the water will be going out to the output port. We can observe in the video. If we turn on inlet valve, we can see the coming water will be going equals to going water, so there will be no increasing or decreasing of water. Now if we turn off the outlet, now the tank will be going to full by slightly. If we turn off, it will stop. If we turn off inflow, it will fill the tank, and after filling, if we off, it will off the inlet valve.
By using these applications, that is Arduino IDE, Pixim Lab and mobile app Blink IoT app, we can control all these appliances like gardening lights, volume of a tank and temperature of a system, and we can all control our home automation system by using our mobile phone. Thanks for giving this opportunity.